Okay, in case we will be cut again, no, kindly click the link again, ha. Click lang. So good morning, no, to everybody. Now let's check the specific examples here, no, and we'll be going into applications now of heat. But there are tables that I will be using probably now when we go into these different examples, no. So that's one. Okay, I will start here now, and then I will just retract now the ones that I show at the top. So an iron rod is 2 meters long at 20 degrees Celsius. No? What will its length no, be at 60 degrees Celsius? No? So this is an example of a problem on coefficient no, or on linear expansion. No? Now we understand not last time that we have no a thing we call as expansions of materials. No? Materials eventually expand now when they're subjected to heat. No? So let's take that up. No? So one thing is materials can have lengths, or it can have an area, or it can have a volume. No? So we understand that finding volume or area no, depends on the dimension of the object. No? So how do you get the area, for example, of a square or a rectangle? Na paano ginakuha ang area sa square or rectangle na? So we can call that as initial area no or initial length no. Now if we take up number 1 here no, example 1 no, so let me move this up. So we have here an example of for number 1 no, we have a given value for number 1 no. Our given is there is no an original length no, we call it LO no, original length no, and our original length for this one no, LO is 2 meters long no. Next there's an initial temperature. I'll call it again no, initial temperature, which we can call as T sub I no, so our T sub I is given to be no, how much was the value earlier? 20 no, it's given to be 20 degrees Celsius, and then its final temperature is also given no? We can call the final temperature as T sub F. Now we usually use small letters no, when we use the common scales no. So Celsius, Fahrenheit are called as common scales no. We use capital letter T when we are dealing with absolute temperature, and absolute temperature no is so that's T sub F. T sub F is 60. Huh? Okay, so what we are trying to find here no, so find no, we will look for no, its LF no, final, we call it as final length no. What is the final length no, of our object no, at a temperature ng 60 degrees Celsius. So we know that our object no will elongate once there is no a heat no added to the material no. Now the final length of the object guys no, so our L sub F is actually equivalent ko no, to the original length of the object plus some added length, no, when it is subjected to heat. No? We call that added length as delta L. No? Let me draw the symbol for delta L. So it simply has this thing that looks like a triangle. No? So that's our delta L. No? Our temperature there. No? So this is our 20 degrees Celsius. And 60 degrees Celsius. No? Now, kung may ara ka-object guys, no, nga gininit mo, no, let's say a rod. No? If this is our rod, we know that this rod, eventually, no, kung initon mo ni sa, there would be a possibility nga malaba na siya, no? It will elongate, no? So ang ining iya nga dugang ko na di amo ning iya nga gin elongate, gin laba yan, no? So primero at an initial temperature, no? T sub I nga 20, no? Degrees Celsius. Ang iya length halin lang di hasta di, no? So that's the original length, no? But after we heat it up, no, nadugangan di sa sang length sa punta, no? So that's the added length that was no, that causes the elongation. Now, we can call this previous value as L sub O, no? Amaning tawag nato ni L sub O, no? This is the L sub O, while ang ining sa punta amaning aton nga naging dugang nga length, no? We can call it as delta L, no? So once you heat up, no, this is what we will eventually see, no? But that will only happen when you heat the object, no? Are you following me? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
One
Yes,
will
sir.
be added only when the temperature is increased, no, from 20 to 60. No? When you cool down the body, it's possible that this one will become shorter. No? So this one is only added when the temperature now is changed into 60 degrees Celsius. No? Okay, so that's the principle or theory. No? We call that as expansion of the material. No? Now, so the final length, no? Ano na karon ang bag-o nga length, no? Where is now the new length of the body, no? So the new length of our body is from this end, no? It's from here up to here, no? Amo na ning kalao final length ya karon. No? And this whole thing, no? Which we will now call as L sub F, no? Amo na ning bag-o nga length, no? New length, no? So this is true, no, whenever we add, no, the original length plus the change in length. But question, how do we get the change in length? No? Paano ginakuha ang change in length? No? Paano na siya gina-determine? No? Now, according to our equation for change of length, no, ng change of length, guys, is equivalent, no? Ang ining delta L natin, it's actually equivalent to a symbol called alpha, no? LO, and we have delta T. No? Mayroon ko di drawing alpha value like that. No? Looks like a letter L, no, in the Greek. No? And then we have another value here which we call as delta T. No? Now our delta T is simply, no, the change in temperature. No? And how delta T? No? Delta T is simply, no, final temperature minus final temperature minus initial temperature. No? So this delta T value, pwede ito ni ma-solve una gid, no? This is the easiest one. So delta T is equals to T sub F minus T sub I. No? And how much will be our delta T? Delta T. So this is 60, no? Minus 20. Now this gives us 40, no? Now, we will realize kung ining 40 karon, no? You'll notice kung ining 40 is the difference of two temperature. Now, if we will make this, or if we will call this as 40 degrees Celsius, we will be kind of misled by those value, no? Masala kita, no? Is 40 there an actual temperature? Is it a temperature, no? Now, you will agree with me nga hindi na sa temperature, no? Because it's a difference of two other temperatures already, no? So therefore, para ma-distinguish na siya nga change in temperature na siya or difference, sometimes ang iyang nga degree symbol ginasulat na siya after sang C, no? So 40 Celsius degree is actually a change in temperature, no? It's not a temperature value, no? Kahit kung ang temperature be 80, no? And then the other temperature is 40, no? So 80 minus 40 is still 40, no? But that's not a temperature value, no? That's a difference in the temperature. So usually delta T, no? There are books that will write it as 40 Celsius degree, no? Do you follow? So these are delta T, and we will add this value here in our expression, no? And then our original length, LO, is given to be 2 meters. So, ang kulang to na lang is this value alpha. No? Now, the value alpha is determined by, no? It is given by our value, no, on listed value na siya. No? So, let's look for the listed value of alpha. No? And I'm going to use, no, our text in okay, so hopefully na wala to nadula ang aton ng screen kayo. Sorry. I kind of read it earlier. Okay, anyway, this is our table. No? From our list of tables here, we have a table for, so this is our first book, no? First book ni natin sa Physics 1. And there's a table there for coefficients of expansion. It is found in page 323. No? And the metal that we are dealing with there earlier is iron. No? And I want you to note down, no, the expansion of iron. No? So 11. So if you see this one, no? So this is our iron. So that's 11 times 10 to the negative 6. No? That unit is Celsius degree. No? Notice mo niyo. So that's raised to negative 1. No? So it is affected by the change in the temperature. No? So 11 times 10 to the negative 6. No? Ang iyang value. No? So let's go back, no, to our previous problem there. No? And I think all of that is gone already. No? So anyway, let's just now write our equation. So we are looking for our final length here. No? So our alpha value is equivalent to, no? Alpha is given to be, no? 11 times 10 to the minus 6. No? And that's per Celsius degree. No? So, and then again, now this is our alpha value. And then next is our, no, we have our delta T earlier. No? Our delta T earlier was 40 Celsius degree. We solved that already. And we just add the symbol. No? And then next is, we are now calculating delta L. No? So what is our final length? No? Final length or change in length, no? Our change in length is, what's our equation for our change in length earlier? Alpha, no, that's equals to alpha LO delta T, no? Alpha LO and delta T, no? So therefore, our expression here is equals to 11, no? Can you multiply for me? 10 to the negative 6, no? That's an exponent, Please take note, that's an exponent. And then LO is 2 meters. And then delta T is 40, no? 40 Celsius degree. And what remains is, since that's a length value, what remains eventually is our unit of meter, no? Unit ng meter lang ang bilhin, no? Can somebody please multiply that? So our value is how much? Are you there?
10 raised to negative 6 na, sir.
Again.
Ang sa 11 times 10 raised to the power of negative 6 or 10 minus 6?
10 to the minus 6 na. 10 to the minus 6. 11,
okay.
then that's scientific notation.
8.8 times 10 to the power of negative 4, sir.
8.8
times 10
to
the power of negative 4 raised to negative 4.
negative 4, no? That's meters, That's meter na lang. Okay? That's a small value, no? Now, if you will try to make it, no, millimeter, no? So, di ba, kung millimeter, siya ko ni mo, tanis siya nga value nga, if you move the decimal place ang 8.8 to the left, no, you'll notice that it can become, no, 0.88, no? 0.88, no? Then that will become 10 to minus 3, no? Meter. And we know that 10 to minus 3 is a millimeter, no? We can also write that as 10.88, no? Millimeter. So, ang malaning iya i-expand, no? This is the only length it will expand. So, therefore, if you will try to find its final length, no? Ang atong final length karon kay kwaon, tama lang iya final length. So, LF, no? Is original length plus ang iyang added length, no? So, if we will add the additional length here, no, 0.88 millimeter, no, then we can find the original length, no, and the final length, I mean, no. So how much is our final length, no? So final length is 2 meters, no. So if we will make it in meters, then we will have to write this, no, in ang 8.8, no, 10 to minus 4, himuon tama na siya nga meter dapat. So there must be 4 zeros, no? Or 3 zeros before 8, no? So if you'll try to move the decimal place here from left to right, so 1, 2, 3, 4, no? So may mo siya 8.8, 10 to minus 4. Ang minus 4 na, ang decimal places from the last decimal point to the left, no? So this is in meter. So therefore, our final answer, no? Amo na ning iya final length. Gamay-gamay na ang iya nga added length, no? Amo na ang iya nga final length. So the object actually changes length, no, by only this much. Gamay-gamay lang yun. It's not so large, no? But eventually the object expands. So this is merely a proof that when objects are subjected to heat, no, then it can, no, change its dimension, no. Now sa number 2, guys, kinahanglan mawala na di ang area, no. So if this is circular, no, ang rod, no, kay may diameter siya nga gina-mention, no. If it's talking about diameter, then it must be considered as a circle, no. How do you get the area of a circle, no? So kung circle, no, so for number 2, all that you will find is its original area, no. Pila iya AO, no. Ilang original area, no? Sa aton object, no? So AO, no, is equals to, kay circle siya, that's equals to pi, no? That's equals to 3.14. And then you get the radius, no? So if its diameter is 0.8, no? 0.8 centimeter, then you get half of that. What's half of a diameter nga 0.8, no? Pila aton radius dire, no? So if you are going to get the radius must be, no, 0.4 centimeter. But how do you write centimeter and make it into a meter, no? Centi is 100, no? Dividing it by 100. So if you divide this by 100, so actually in meters, that's 0.12, no? Bandugang kapag iduwa ka 0. And that will now become a meter, no? So sa aton nga area sang circle, all that we do, no, or ang kulang de, is actually, no, use the value use the unit, no, in meters, and you square, no? You square this and multiply it to pi, no? Then you can get the original area, no? So to find the change in its ang nga delta L, no? Delta A naman, no? So the area is like this, no? So to get the change in area, so we call it delta A. Ang atong delta A naman din, we have our symbol, no, na beta times A sub O, no? Then we get the unit, no, delta T, no? So you need your, so this will be delta A, change in area, no? Sorry. Suppose so change in area, no? And you have your beta symbol after this. So beta is our coefficient of beta, pwede ka man na gamitan na lang sang letter B, guro. Let's just use the unit. Ang symbol ng B. Beta, no? So beta is ang aton value nga beta, if it's a metal, no? So beta is 2 times, no? 2 times of your alpha value, no? So for metals, we simply double, no, the value. So if earlier we have a rod, no, nga iron rod, no? So i-times 2 mo lang to, no? So ang ining 11 times 2 mo lang na siya, no? So if it's doubled, no, then you'll see that this one will simply be equivalent to, no, 22, no, times 10 to minus 6, no? 10 to minus 6 na, no? And that is still in Celsius degree, no? So that's the relationship of alpha and beta, no? We simply multiply it. And if it's volume, then we simply triple the unit, no? So we use a symbol for volume naman, no? So for area, amo ni beta aton ginausa. For volume expansion, no? Then we use the gamma symbol, no? So gina-triple ta lang na. No? So ang gamma naman niya, the symbol of gamma, sometimes they use this the letter Y, no, like that. Something like a letter Y symbol. No? Gamma na siya, gamma symbol. No? And gamma is simply 3 times. This is actually 3 times our alpha value. No? So if you are dealing with an iron rod, no? And the iron rod is having now a volume, no? So 3 times alpha lang na siya. No? Okay, so gamma is for volume expansion, beta is for area expansion. No? So if you have 22 dire times ang iya original air sa babaw, kag ang change in temperature nga, ang atong change in temperature earlier nga 40 man gyapon, no? Okay, we subject it with the same change in temperature, no? Then we can find our change in area. No? So ang change in area, i-add mo sa original area, then you'll get the final area. No? So this expression ini is always applicable even to area and to volume, no? Including the change in temperature. No? So when we deal with change in temperature, no, or change in, not change in volume, no? So for delta V, no? Change in volume, then we deal with original volume, then gamma, no? May gamma kada ibutang. Then you'll have here your delta T man gyapon. No? So gamma is added here. And then your change in temperature, which is always initial minus final temperature. No? So I think this one, no, is change in volume also. No? You need change in volume. No? So you will see that there's a similarity to our expression. No? Whether it's change in volume, change in area, or change in length. No? So we need the original lengths, volume, and area, and multiply it to the change in temperature. No? So any question from you? So for number 3, pwede nyo na siya pangitaon. Anong volume sang sphere? Ang copper ball is a sphere, no? So ano nang iya original volume? So you'll need there the 4/3, no? Pi r cube na formula, no? Kung area ya sang circle, it's pi r square, no? That's how we get the area of a circular of a circle, no? Pero kung sphere, ang volume yun na iya is 4/3 pi r cube, no? So you need some ways of how to calculate volume, area, no? And except siguro sa length, no? Okay, I think pwede nyo na mag-try, no? Ining number 2 and number 3, no? And ang ako lang idugang karon, what I will be adding is simply the formula for our change in phases or in the mixture nga problem, no? Okay, no? So you can complete these expressions, no? So again, no, for our linear expansion, so let's have a summary, no? So linear means length, no? We have our final length, no, to be equal to LO plus delta L, no? For our area expansion, then we have AF. So AF is our final area. So you need there the original area plus the change in the area, no? Ang na-add nga area, no? And then finally, our change in volume, volume expansion. So our final volume or VF is equals to V sub O, sorry, plus the change in the volume. No? Okay, wala na, no? So that's how you get the different values. So for our change in area delta A, no? So amo na ding ibutang mo. For change in volume or delta V, this is what you add there. No? Okay, so we have a minute to go, no? And I hope you basically have this, no? So you can copy the different formulas that we have there, no?